Hello friends, this is Sam again, and the next topic we're talking about now is Euler-Cauchy equation. It's also for the second order ODE equation. We also use this for second order ODE equation, and this time around, instead of having constant coefficients, we'll be having a kind of x square x coefficient in our equation instead of having constant coefficient. So, for example, if you have x squared y prime prime plus ax y prime plus by equals 0. In this kind of equation, you need to represent y to be x raised to power m, and you can be able to differentiate this. Then you have y prime, no, sorry, y prime to be, you need to differentiate this. M will go to the front, x, then m minus 1. And also, y prime prime will be m will also m minus 1 will go to the front also. Then you subtract this power by 1. M minus 1 minus, that's minus 2, right? You have that. Then you can replace all these values. You can, transfer these values into this equation. Then you have x squared m minus 1, then x m minus 2 plus this a x, what's our y is what, m x raised by m minus 1 plus b, our y is this, x raised power m equals 0, and x squared, then you can bring this x to this side. Because of this power, we have plus m minus 2. This we cancel this. You're left with x raised power m. Then this m will follow. Then m minus 1 plus ax raised power 1. Then plus this m minus 1 law of indices. This will cancel this. Then you're left with m plus bx raised power m equals what? 0. And from here, we can say m bracket m minus 1 x raised power m plus am x raised power m plus bx raised power m equals 0. M squared minus m, then all this can come out, then equals to 0. So we're left with this plus am plus b equals 0. Then we can have m squared factor coefficient of m. You have plus a minus 1 m plus b equals 0. So when you get your value of m, you also have different cases. So case 1, it's when you have real, distinct, or different roots. In this kind of case, your y1 x equals what? X raised to power m1, and your y2 x equals x raised to power m2. Then y equals c1 x raised to power m1 plus c2 x raised to power m2. Then for case 2, that's a real double root. In this kind of case, when your m1 equals to your m2, in this case, you say y equals c1 constant, c2 ln x raised to power m. Yeah, that's all. It's almost like that, but it's almost like the constant coefficient that we did earlier. But in that case, you only have c2x, then e instead of x, e raised to power lambda x. But in this case, you have c2 ln x brackets x raised to power m. And that's for the case 1 and case 2. So from here, we can try to solve questions on these two cases. For instance, if we're given, let's say, if we're given this question, let's call this question 1, x raised to power 2 y prime prime minus 20y equals 0. What you have to do is the solution will be in form of y equals x raised to power m, right? So this is how you start. Then start building other things from here. So y prime equals what? M x raised to power m minus 1. And your y double prime equals, move this to the front and subtract by 1. You have m brackets m minus 1 x raised to power m minus 2. Y prime prime equals what? Okay, so yeah, we can move from, okay, so then we can put all this into our equation. You have x squared. The y prime prime is what? M brackets m minus 1 x raised to power m minus 2, then minus 20, and our y is x raised to power m equals what? 0. From here you can say x squared dot x m raised to power 2 dot m minus 1 minus 20 x raised to power m equals 0. X, this can cancel, so we have m, then m squared minus m minus 20 x m equals what? 0. xm equals 0, or all this equals 0. So you have m squared minus m minus 20 equals 0. Then from here, you can find, you can use your calculator, or let's do it one after the other. M squared minus 5m plus 4m minus 20 equals what? 0. m minus 5 plus 4m minus 5 equals what? 0. M plus 4 m minus 5 equals 0. So m equals minus 4, or m equals 5. Then from here, you can put in the equation, the values into, because we have distinct value of m, then you can use y equals c1 x raised to power minus 4 plus c2 x raised to power 5. So that's our general solution. Thank you.